Structure of main pump and how it works. The K3V112 hydraulic pump consists of the following components: the pump body, which supplies hydraulic fluid as a variable displacement axial piston pump of the tandem double pump type. The pilot gear pump, which produces pilot pressure and supplies hydraulic fluid. The regulator, which controls discharge flow rate, and the EPPR valve, which controls each excavator mode. How the main pump works and its components. The main pump consists of three groups: rotary group, swash plate group, and valve block group. The rotary group consists of the following main parts: drive shaft, cylinder block, piston assay, set plate, spherical bush, and cylinder spring. The drive shaft is supported at both ends by the needle bearing. The shoe is swagging on the piston and attaches to the spherical sides. This reduces the axial force produced by load pressure and slides on the shoe plate. It therefore has a pocket to maintain hydraulic pressure. In the subunit comprising piston and shoe, a cylinder spring is inserted into the set plate and spherical bush, which pushes toward the shoe plate to smooth sliding on top of the shoe plate. In addition, the cylinder block also pushes on the valve plate via the same cylinder spring. The swash plate group consists of the following main components: swash plate, shoe plate, support, and servo piston assay. The tilt angle of the swash plate changes the piston hole's maximum capacity and determines the hydraulic pump's discharge flow when the RPM stays the same. The higher the tilt angle of the swash plate, the higher the discharge flow, and the lower the swash plate's tilt angle, the lower the discharge flow. The valve block group consists of the following main components: valve block, valve plate, and valve plate pin. The valve plate, which has two kidney ports, is fixed to the valve block, supplying and collecting hydraulic fluid to and from the cylinder block. The piston moves away from the valve plate within 180 degrees, which is the suction process, and moves toward the valve plate in the next 180 degrees, which is the discharge process. In summary, the rotation of the cylinder block and the tilt angle of the swash plate periodically increase and decrease according to the capacity created by the piston and the piston hole of the cylinder block, and the pump thus sucks and discharges hydraulic fluid. Introducing the regulator components. The regulator consists of the following components: spool, sleeve, pilot piston, lever 1, compensator piston, compensator sleeve, feedback lever, lever 2, and servo piston. How the regulator works. Power control. when one's pump discharge pressure increases along with the counter pump. The regulator goes into motion and adjusts the swash plate's tilt angle in order to reduce the pump's discharge flow and restricts the input torque to within a certain amount. Power control's load prevention function. When one's pump discharge pressure increases, as along with the counter pump, the pressure applied to the compensator piston increases. When the pressure is higher than the force of the pressure spring, the compensator piston moves left and the lever, with the pin at its center, rotates clockwise while the feedback lever rotates counterclockwise based on the lever's movement. Other connected spools move left due to the counterclockwise rotation of feedback lever. The pump's connection circuit opens from the spool's movement. The hydraulic fluid flows into the servo piston's large cell. The servo piston moves either to the left or right according to the area of maximum and minimum diameter. It also moves the swash plate, and the swash plate's tilt angle decreases. The pump's discharge flow decreases because of this and prevents loading. With the servo piston's movement, the feedback lever rotates clockwise, centered by the pin. The feedback lever's rotation moves the connected spool to the right and blocks the connecting large cell's flow path. Recovery function of the power control flow rate. When the pump's discharge pressure decreases, the pressure on the compensator piston decreases. The compensator piston moves to the right by the spring's force, and when the compensator piston moves to the right, the lever rotates counterclockwise, centered by the pin. The feedback lever rotates clockwise under the lever's movement. The connected spool moves right as the feedback lever rotates clockwise. The oil tank circuit opens by the spool's movement and connects to the servo piston's large cell and the oil tank. The large cell's high-pressure oil is discharged, and the servo piston moves to the right. This moves the swash plate, increasing the tilt angle of the swash plate, which in turn increases the pump's discharge flow rate. The feedback lever rotates counterclockwise due to the movement of the servo piston. The connected spool moves left from the turning of the feedback lever, which blocks the drain and the large cell's fluid passage. Priority functions of the power control. Flow decrease command. The flow rate and horsepower control command is transmitted to the feedback lever and spool through lever 1 and 2 large holes. There is a small pin attached to the feedback lever in the large hole. The small pin touches the flow decrease flank of the large section, but is disconnected from the flow increase side. The flow rate and horsepower reduction command therefore takes priority in actuation to the increase command. Power shift control. The variable horsepower is controlled based on the pilot pressure. The horsepower setting value is shifted with the changing command current of the proportional pressure reducing valve, which is a regulator part. There is one proportional pressure reducing valve, but the secondary pressure PF power shift pressure guides each pump regulator's horsepower control through the pump's internal passageway, which shifts each horsepower setting to the same value. Through this device, the pump's output power can be randomly changed, so it is possible to attain the optimum power to suit the operating situation. Please refer to the following picture. When the EPPR valve's current increases after receiving the MCU signal, the secondary pressure value of the EPPR valve also increases relatively, and the PF pinhole pressure increases. The compensator piston moves to the left when the pressure is high, then the spring's force and lever 1 rotates clockwise, centered by the pin. The feedback lever rotates counterclockwise under interlocking with the lever. As the feedback lever rotates counterclockwise, this moves the spool to the left. The spool moves and opens the pump circuit. As the hydraulic fluid flows into the servo piston moves to the left due to the difference in area between the large cell and small cell, and moves the swash plate so that the tilt angle of the swash plate decreases, which reduces the pump's discharge flow to prevent loading. The feedback lever rotates clockwise with the servo piston's movement. The connected spool moves right and shuts off the pump circuit while reducing discharge flow and preventing engine loading. When the EPPR valve's current decreases after receiving the MCU signal, the secondary EPPR valve pressure value also decreases relatively, and the PF pinhole's pressure decreases. The compensator piston moves to the right with the force of the left spring, and the connected lever rotates counterclockwise. The feedback lever rotates clockwise under interlocking with lever 1. As the feedback lever rotates clockwise, the spool moves to the right and opens the drain flow channel. The servo piston's large cell and the drain become connected. The high-pressure oil from the large cell is discharged, which moves the servo piston to the right, moving the swash plate. This increases the tilt angle of the swash plate and increases the discharge flow of the pump. The feedback lever rotates counterclockwise, centered by the pin, with the movement of the servo piston. The spool moves to the left with the rotation of the feedback lever, which blocks the drain passageway and increases the discharge flow to augment work efficiency. Negative flow control. When negative flow control takes effect, the user can learn the operation state of each MCV spool and control the pump discharge flow through the foot relief valve, installed at the end of the MCV central passage. Negative flow control pressure is connected to the main pump's regulator, which is connected through an external hydraulic hose, and through this the regulator moderates the main pump's flow quantity. Negative flow control. Flow decrease. When the MCV's negative flow control pressure is at its minimum, the main pump's discharge flow rate is highest. When negative flow control pressure from the MCV increases, the pilot piston overcomes the spring power under the increased pressure and moves to the right. Centered by the pin, the lever rotates counterclockwise with the movement of the pilot piston. In response to the lever, the pin-centered feedback lever rotates clockwise. The spool connected to the feedback lever by the feedback lever's rotation moves to the right, opening the pump circuit. The high-pressure oil then flows into the large servo piston cell. From the difference in force created from the difference between the servo piston's large and small cell areas, the servo piston moves to the right, which moves the swash plate, decreasing the swash plate's tilt angle to reduce the main pump's discharge flow rate. The pin-centered feedback piston rotates clockwise with the movement of the servo piston. The spool connected to the feedback lever's rotation moves left and shuts off the pump circuit. Negative flow control. Flow increase. When the MCV's negative flow control pressure is at its maximum, the main pump's discharge flow is lowest. When the negative flow control pressure from the MCV decreases, the pilot piston moves to the left in response to the spring's force due to the decrease in pressure. The pin-centered lever rotates clockwise as the pilot piston moves. The feedback lever rotates counterclockwise under linkage with the lever. The spool, which is connected through the feedback lever's rotation, moves to the left and opens the drain's oil passage, connecting the high-pressure oil to the servo piston's large cell drain, reducing pressure. The swash plate moves as the servo piston moves to the left, increasing the swash plate's tilt angle, which increases the pump's discharge flow rate. The pin-centered feedback lever rotates counterclockwise from the servo piston's movement. The spool moves to the right from the feedback lever's rotation, which cuts off the pump's flow passage. Input horsepower adjustment. Adjusting the flow control quality. Loosen the hexagonal nut and either tighten or loosen the adjustment screw to modify the flow control quality. Please refer to the following picture. Adjusting the discharge horsepower, outer spring. Loosen the lock nut and either tighten or loosen the adjustment screw to modify the outer spring and change the primary horsepower control quality. Horsepower increases by tightening the screw and decreases by loosening it. Please refer to the following picture. Adjusting the inner spring. Loosen the lock nut and either tighten or loosen the adjustment screw to modify the inner spring and change the secondary horsepower control quality. Horsepower increases by tightening the screw and decreases by loosening it. Please refer to the following picture. Adjusting the maximum discharge flow rate. Loosen the hexagonal nut and rotate the maximum discharge flow control screw to change the maximum discharge flow rate. When the maximum discharge flow control screw is wound counterclockwise, the maximum discharge flow rate increases, and when wound clockwise, it decreases. Please refer to the following picture. Adjusting the minimum discharge flow rate. Loosen the hexagonal nut and rotate the minimum discharge flow control screw to change the minimum discharge flow rate. When the minimum discharge flow control screw is wound clockwise, the minimum discharge flow rate increases, and when wound clockwise, it decreases. Please refer to the following picture. Pilot gear pump introduction. The pilot gear pump's primary function is used when providing the excavator with pilot control oil. The external gear pump is therefore also referred to as the pilot pump. In addition, the pilot pump provides subsidiary control oil pressure for adjusting the main pump power. The main components are as follows: front case, gear case, drive gear, driven gear, and pilot pressure control device. How the pilot gear pump works. The pilot pump consists of drive gear, driven gear, gear case, front case, and relief valve. The drive gear and driven gear create two sealed enclosures during suction and output. When the gear rotates, the interlocking gears from the suction side slowly rotate to gradually increase the sealed space and create a vacuum. The oil in the oil tank then moves to the suction side in response to external air pressure. Simultaneously, the output side capacity decreases, which compresses the oil in the space between gear and case, discharging oil on the output side. Maximum discharge pressure can be adjusted by the relief valve in the front case. Rotating the screw clockwise will increase pilot pressure, and clockwise will decrease it.